All right, we're doing the observation versus inference notes. So make sure you do split screen on your iPad or minimize this screen or make it small so you can write as you go along. Write on your notes, which should be a PDF open in Notability. So first, pause the video here, take the pre-test on pages 1 and 2, and we will correct it and go over the answers, and you're giving yourself a score. Again, it's a pre-test. Just see if there's any of these vocab words or ideas that stick out to you. And we'll eventually get through all this information in class. So pause here. Okay, let's go through the answers now. I will do my best to write this out. So scientists set up an experiment. They at least have two parts. The part that never can change, that changes, is the control. Blank is the application of science for practical purposes. That's technology. Technology. Feel free to watch at 1.5 speed here in the bottom corner of your video as I write it. Explanation of, so the big key here is why something is happening based on observation. This is a scientific, so I'm going to abbreviate, scientific theory. Theory is all about why it's happening. It's an explanation of why something is occurring the way it's occurring. Blank is the ability or willingness to assess claims critically. It says critically right in it. This is critical. Apologize for my spelling. Thinking. Critical thinking. These are all in your word bank. You're using each one once, so I'm just going to make it short. Critical thinking. Blank, or sorry, when you collect information and experiment, that's called data. D-A-T-A. Really nice if they'd let me type here. Blank is the measure amount of matter. That is mass. So we're doing some measurement this unit as well. And here is a series of steps, a way of thinking that helps you collect data, formulate hypotheses, and so forth. That is the scientific method. Okay, you're just correcting whether they're right or wrong here. Blank is the measure of the size of an object or how much space it occupies. That would be volume. I'm getting a little bit better at writing here. Going on to the next page. Blank is a factor that changes based on the experiment, and you're seeing what impact it has. That is variable, V-A-R-I-A-B-L-E. Believe it or not, this is probably better than my actual handwriting. Blank is the measure, it is length or distance, the straight line distance between 2 points. That is length or distance. You'll see them used relatively interchangeably. Blank is the amount of gravitational force exerted on an object. That is gravity. Blank is a method of expressing quantity multiplied times 10. So that would be scientific. I'm totally blinking. I'll come right back to that. Is a description of how close a measurement to the true value. That is accuracy. A-C-C-U-R-A-C-Y. Accuracy. Scientific notation. Sorry, I don't know why I blanked on that second word there. Scientific notation. I don't have the words right in front of me. So that'd be why. Exactness, if that's accuracy, this one is precision. So think about accuracy as if, say you weighed 150 pounds, okay? And you stepped on a scale and it said 180 pounds. You'd be like, well, that's not very accurate. But if you stepped on the scale and it said 180 pounds every single time, that would be a precise measuring tool, but it would not be very accurate. Now, if I stepped on the scale and it said 150, that'd be really accurate. And I stepped on the scale every time, 150, 150, 150, it's accurate and precise. But if I stepped on the scale and it said 150 one time, 151 a different, 149, it's about 150 averaging out. We'd say it's pretty more accurate than it is precise. Knowledge gained by observing. This is science. Science. And the last one, if the other one was theory, this is what is happening based on results and observation. A lot of times these are math equations. This is a scientific, which I'm abbreviating SCI, law, scientific law. Okay. So make sure that you're crossing these out, giving yourself points for the ones that are right, and so forth. Hypothesis can never be proved wrong. That's false. Obviously, I could say that I think the sky is green, walk outside and be like, oh, it's blue. Hypothesis is wrong. No experiment is ever a failure. That's true, because even in that example, I learned that the sky isn't green, right? So even if even if my hypothesis is wrong, the experiment itself might not be a failure. And then here we have a scientific method happening. The first thing we do is we identify a problem. We need to determine the acceleration of gravity. Next, we develop a hypothesis. I'm estimating the acceleration due to gravity. Then we perform an experiment, and then we draw a conclusion. And that is my pretest. So on the bottom of your page, you should have a score that looks like this. So I got 22 out of 22, so that's what I'm going to put in there. I'll be looking at that when you submit your notes. So now let's talk about observations versus inferences. The actual notes portion of this starting on page 3. So let's take a look at this image, and I want you to make 3 observations. And I pause the video here, make 3 observations, and then write them in your notes where you got 1, 2, and 3 there. Any 3 observations. So pause the video. Okay, so now we're going to talk about the difference between observation and inference, and then we're going to come back and revisit those observations that you made. So first thing, when I'm observing, I'm using my 5 senses, right? I got all my 5 senses here in order to gain information about something, my surroundings, an experiment, whatever it might be. An observation is a statement, recording, or comment of a fact. So if I look at this image, many of you probably wrote what was actually an inference. An observation would say that this person is standing in a body of water. These are observing, this is a body of water. It could be a river, it could be a lake, it could be an inlet, it could be a dam. There's lots of different pieces that it could be. And then many of you maybe said man. Well, there's no guarantee based on a silhouette here that that is actually a man. We can infer that based on general characteristics, but it's not actually for sure. And then you see the fishing pole there. Maybe you're saying, oh, it was fly fishing. Okay, well, again, that's an inference that requires prior knowledge. So an inference is a conclusion using facts, our observations, and prior knowledge. So it's an interpretation of facts. So when we're making observations in science, the inference is a conclusion that we draw based on the data, the trends that we see. So the observation is the person is standing in the body of water holding some type of stick. The man is fly fishing is an observation. Saying things like it's foggy is maybe even an inference, right? We don't know, it could be camera work or something of that nature. And I'm being very facetious right now, but I want you to understand the difference. So before and after labs, we are recording observations, and inferences are found in the conclusion. So a lot of times when I read lab reports as an example, people are writing inferences into their results section or into their methods. We need to make sure that when we're collecting data, we make observations and that we leave the conclusions, we relieve the bias or the conclusion at the end. So reconsider your observations. Go to the top of your notes and circle any that you think are actually inferences. And I want you to remember that at any point in time, you can pause the video and write things down if you have to. Okay, you can slow it down or speed it up, whatever you need to do. So now we have some silly photos here, but I want you to just look at it and make an observation, or we got an observation and inference, and we're going to evaluate. So the first statement, the left side of the highway has more cars in this stretch than the right side. Yeah, you can even say, well, highway is inference. You're right. Okay, but the idea here, that's an observation, right? I can say that the number of vehicles over here is greater than that side of the divided road. So that one would be an observation. The circled car is facing the wrong way. What do you think? Yeah, I mean, we actually don't know. So that requires us to guess that this car is not moving, that it doesn't have a weird shape or whatever it might be. It looks like it's facing the wrong way or driving the wrong direction, but that would be an inference that requires us to draw a conclusion, right? So let's look at this photo next. We got kind of a funny situation here. We got 2. The boy missed his set. We actually don't know that 100% for sure. That would be an inference, right? It looks like his hands are set for to set the volleyball, but maybe this is a new technique the coach is teaching them. This guy seems mildly interested in what's happening. Okay, the coach is unimpressed by these. That's body language and vision. I mean, if that were me, I would probably be stifling laughter right now. You know, but whatever it is, again, those are inferences or conclusions that we're drawing. So let's watch this GIF here, and I want you to write one observation and one inference on your notes and record why. Think about what the definition of observation is, what the inference is as well. So we can watch this a few times and go from there. I love this one. Okay, now submit your assignment or your notes, this whole notes, and then this is actually your assignment, is the observation and inference and why you think so. That's your assignment via Notability. So remember, go to the upper left-hand corner. You're going to hit the box with an arrow, and then you're going to go down to Other Pages, find Schoology, and then upload it to the observation versus inference assignment. And that's what you're doing, and then we're done. Let me know if you have any questions. Email, reach out, etc., etc., etc.